Hey there, my name is Rohit Kumar, and today we are going to discuss a very important concept that is object-oriented programming. Though it is a concept, but it is offered as a full-fledged course in many UG and PG programs, and it is quite important for computer science section. So let's start with the basic concepts. This is the short lecture introductory slide. So we are going to have the basics. Now, first thing first, that what is an object-oriented programming system? So any object-oriented programming system is going to have some of the related properties, and those properties are encapsulation, abstraction, polymorphism, inheritance, class, and object. So you may read these properties in clockwise direction as well as anti-clockwise, doesn't matter. But from understanding point of view, I recommend that you go in anti-clockwise direction. So if we go like this, then the first property comes, that is object. Means every object-oriented programming system should obviously have some objects. So what are objects? Objects are nothing but some entities. Now, what are entities? So when we discuss the concept of entities, so entities holds some of the related properties, means anything having some of the attributes or properties is an entity. So not necessarily it should be a physical entity, it might be some logical entity. Now, when we discuss the concept of object, then the concept of class automatically comes into picture, because object and class are so related that if you leave one of them, then it's difficult to understand the other one. So we will also follow the same concept. We will also take the class discussion side by side. So class is nothing but the collection of related objects. So it is object 1, object 2, and like this object n. And all these are the instances or the examples of class O. Okay, so there is a class O, and there are different objects, object 1, 2, 3, all belonging to this particular class. So this object means the entities. They have some properties, means attributes. Like if you want to take some example, then for example, there is a class human. Okay, so human is a class. Then if we take the object, means the instance of this particular class, that might be Ramesh, that might be Suresh, that might be Meena, that might be Sita, etc. Means anything who is a human is an instance or is an object of this particular class. Okay, so in this way, we can define the concept of objects and class. Now coming to the concept of inheritance. Inheritance says, suppose there is a class C1 and there is another class C2. So if both these concepts, both these classes are part of, not part of, are the subclasses of some third class C3, then these two classes are going to get some of the properties inherited from class C3. Then it is called inheritance. This process of inheriting something from the upper level class is called inheritance. For example, children do have some of the related properties from their parents, means that they do acquire some of the inherited information or traits from their parents. It is nothing but the inheritance. So C1, C2 might be two siblings, and C3 is the parent. Then the parent's trait might be present, not all the traits, but some of the traits, some or all the traits. If they are inheriting, then the process is called inheritance. Moving on, we will discuss the polymorphism. Polymorphism means the ability to take multiple forms. Ability to take multiple forms here. So when we say multiple forms means that suppose there is an operator plus. So this operator is working as an addition as well as it is working as the enhancement of something. Then this operator is the overloaded operator. Similar way, if there is a function add, this add function when getting applied onto integer, then giving you the arithmetic, but when getting applied onto strings, then it is giving you the concatenation. Then this function add is also working two-way. It means both these, the function overloading and operator overloading, are examples of polymorphism. Moving on, we have the abstraction. Abstraction means vagueness, means when you define something in a vague way. Vague means there is no exact clarity. then it is a state of abstraction. Why it is important? It is important because in many of the cases, when we do need the security requirements, then we don't want to reveal our inner details, the fundamental details of some system. Then abstraction becomes a very useful concept. Lastly, but not least, is the encapsulation. Encapsulation means what? Like we do have a capsule. This term came from this thing only. We do have a capsule. Capsule has two parts. Similar way, when you put two things, means data and function together in a single entity, then it is called encapsulation. So why it is important? Because whenever you are defining something, you should have some basic information, that is data, and you should also define the way to handle this data, that is function. And by the combination of these two things, any entity forms up. Okay, so the same concept get applied to object, the same concept gets applied to your structures, unions, etc. So structure unions are part of C, and coming to the object-oriented programming, we have the object classes. Okay, so the things are incremental. From procedural programming, we have shifted to the domain of object-oriented, but some of the related concepts are present here. Now, when we are discussing all these things, one thing comes to mind, that why these things are important, means why do we need object-oriented programming? Why not we are working with the same procedural programming? So let me tell you this why question. Now the answer to this why question is this, that in procedural programming, we had a standard procedure that the control will move in a specific direction from top to bottom will move. So we have some of the global data. Firstly, we'll define some global data, then we define some of the functions using this global data, and they have their sum of the local data also. Then once you have defined the functions, then from one function you may move to another function, from another to another, but there is a specific flow. But in object-oriented programming, there is no such flow. Randomly, you can start from anywhere. Randomly, you may end at some point, and there is a very random relationship among the functions as well as the data. Now, it is not about the relationship only. The main concept, as I told you, that the main thing in object-oriented programming is the inheritance and polymorphism. So until you encapsulate means these properties into the data or the functional definition of the objects or the classes, then it's not possible to move further with object-oriented programming. So that's why it's highly recommended that firstly you work onto the basic concepts of object-oriented programming. Then you will understand the fundamental concepts of object-oriented programming. Now, as we are studying that these are the fundamental concepts, one basic point comes to mind, that procedural programming had some of that related drawbacks, like there was a usual flow, as well as there was no such presence of object-oriented programming. But if we, and the object-oriented programming is so important and it is so good, then how to design it? So this how component comes next. Firstly, whenever you are going to design an object-oriented programming system, you need to define an object. Okay, so we are going to define an object. Then we are going to move from this object step to class step, because now this is also a very debated topic, that many people say that we need to define object first. Some say that we need to define the class first, because if we don't have the class, how you are supposed to define or initialize objects? So point is that when you do some work at thinking level, at conceptual level, firstly you have to think of object. But when you actually practically implement in some programming language, you need to define the class first, because unless you define the class, you cannot create its object. So that is the main reason that this thing is shown at conceptual level, that firstly you think of an object, that what is that object, then what are the similar objects, then you form a particular class, then you maintain the relationship among those classes, that is inheritance. Then you define some of the related functions, and the different functions are performing different tasks, that is polymorphism. Then you try to hide the necessary details, means crucial details, that is abstraction. And finally, you put all the things together and form a useful entity, that is encapsulation. So lastly, it is not always necessary that you go like this only, means follow all these steps in this. means the order might be different. Again, it is debated. People might debate that it is not the exact order or something like this, but it is one of the standard order in which you can think of the things. Okay. Now, as we have gone through the basic details, the fundamental thing again come to mind that if it is so important, then why we are not discussing the concept of classes and objects at practical level. So let's discuss the class and object concept at practical level. In class, you are supposed to define some of the fields, as I told you, that some of the data you need to define. So you are going to define some of the fields, and you need to define some of the functions, means methods. So this is nothing but data, and this is nothing but the functions. Okay. Then moving on to the concept of object, you have defined the class, as I told you that in programming, you need to define the class first, then you will create the objects. But at conceptual level, you will do the vice versa. Now, you have defined a class, suppose. Now you are supposed to create the object. So you can see that the data and functions which are defined in class, those are only supposed to get used at object level. So name is a field, means name is a data defined in class, and this object is using this name field and defining its value as object 1. Similarly, size is another data field, and here the size is defined as 2. When you are coming to object 2, then it is the values are object 2 and size 3. Coming to object 3, you have the object 3 and size 2. So each object has its own values for the fields, and the respective functions are found in the class. So by default, those functions are present for the use with respect to these objects. How to use those functions, etc., we will see in detail later on in our detailed lectures. But as it is a short lecture, we are going to cover the things in a fast way, just to give you the basic and the exact meaning of the fundamental concepts. So let's move further. So next thing is the class and the objects example. We have understood that what is the class, what are the objects. Now, when you see these things in real world, how it looks like. So suppose there is a basic skeleton of a class that is car. Okay. So basic skeleton has some of the things like the lights, tires, body, chassis means, and the gearbox, etc., etc. All those things are part of every car, means all those things are part of the class car. But when you define the objects of this particular class, then this car turns into either Audi or Nissan or Volvo or Maruti, etc. Okay, means there are different variations of this particular car depending on what color it is holding, what are the dimensions of the parts which we discussed over here, then what are the quality materials that you are using in that, and some of the other specifications which are respective to the different brands. So all these things means the basic thing turns into a specific thing, then you move from class to objects. Now coming to the actual principles which are governing all these concepts and the theory. So there are some basic fundamental object-oriented programming principles, and those principles are nothing but the properties. Now here you are going to define those properties in terms of some basic definitions or the rules or the principles. So as I told you that encapsulation is what? When an object only exposes the selected information, then it is a kind of abstraction. Okay, but in encapsulation, you are putting both data and function together. So suppose it is your data, it is your function. Now with the help of function, you are accessing the data. So in encapsulation, you are putting both these things together and exposing the data which is required and hiding the data which is not required to be seen by the respective user. And this particular resultant form comes in the form of abstraction, means the complexity is hidden just to reduce the complexity or for security reasons. Then you have the concept of inheritance, where the entities can inherit the attributes, and finally the polymorphism, where the entities can perform more than one task. So hopefully you have understood all these concepts well already. Moving on to the basic example. So we have already seen the car example, but here we are defining the data and functions in the form of attributes and methods, as we had there also, but here we are using the pseudo definition of the functions. So we have the refuel, means the get fuel function. Then we have the set speed, get speed, and the drive function. But the attributes here are the fuel and max speed. So all these functions are defined with the help of these attributes. Okay, so this data is used at these functions, and finally you have the basic working model of a particular class. Then moving to the real life example, because we have seen so much details of everything conceptually, fundamentally, but when it comes to real life, how it looks like. So see here, object-oriented programming looks like this in real world. Suppose there is a real world dog. Okay, now dog, is it a class or is it an object? So it's a class if you just simply say it is dog. Okay, but when you say that this is Tommy, this is Harry, this is something else. Okay, so then it becomes a object. Same thing means in class dog you have a particular parameter that is name, but when you assign some value to this name like Tommy, then it becomes a object. So hopefully you have understood the concept. Then you have some of the related attributes, like as I told you, the name, height, weight, food. But when these attributes are used by some of the related functions, then only this particular object can perform some functions, like it can run, it can play, it can eat, etc. Okay, so to perform some function, you need some data. For example, the object cannot perform the eat operation without food. Okay, similar way, it cannot run without the leg or the area. So in this way, some of the related attributes are there, and with the help of attributes, it is supposed to perform some of the related functions. Okay, some of the functions might be there which are not using data at all, but those are kind of highly independent functions, because those functions are kind of just simply printing something, not taking any data. So non-data based functions can also be defined. So that is the fundamental concept of class in real world. Now moving on, coming to the pseudocode example, because ultimately the topic or the course is focused on object-oriented programming. So the real world objects you are supposed to turn into programming form. So as I told you that there was a class dog. So here you are supposed to define the class. So there it was dog, here it is circle. Okay, so in circle you are supposed to have a radius and some color. So it is always not always necessary that you have only two data set, but you may define more data, and depending on the parameters your data set will just extend. Then you have some functions. So these are the attributes or the methods which are defined with respect to these data or this class. Then when you created the objects of this particular class, means instances, then you have the circle type 1, circle type 2, circle type 3, means C1, C2, C3. There you have defined the value of radius, that is 2 blue, 2 red, 1 red. Now you might say, sir, here also we have defined the value of radius and the color. So these are the default values. Means if you are using the concept of constructor, then by default these values are going to assign to some of the object for which you have not defined some of the related values of the functions. Now what is the constructor, etc., that we will discuss in the later classes when we will discuss all the things in detail. So this is the introductory lecture. So just to keep it short and simple, I'm not discussing all the related concepts. So that is the thing. Hopefully the basic and the fundamental concepts must have gone cleared. Still you have some of the related doubts and you don't get something, then you may go through some of the related references. Most of these references are taken from internet only. Even all the references are taken from net only. So everything is available online, just you need to figure out. Then if you want to contact me for some of the related queries or some of the related videos or something, then you may have the related uh, contact information from your colleagues, or you may find the related information at my webpage or at the YouTube channel or the LinkedIn page. So that's all from my side. If you didn't like anything, please do comment below and criticize, because that's most important. And I will try to incorporate your suggestions in my next videos. That's all for today. Thanks for watching. Happy learning.